talk about rational numbers, usually they're going to target fractions. Considering you've been multiplying and dividing wonderful fractions together, oh yes, now you're going to be adding and subtracting them. Okay? What do you need when you have weird fractions? You're adding it. Oh, common denominator.
We all go. All you have to do is multiply each one by the bottom.
It's going to be ugly.
7.
That's so pretty.
6. 6. 4, 6.
All right. So first of all, let's do a quick review about something here. Oops, this is m plus 1 for set of m. All right, so we've had something like this in the past. This is probably one of the most difficult ones you've had from the past, but this is the most simplest one that you're going to have today.
This
It's
problem.
going to get ugly after this, but I want to give you a heads up about how you find the least common denominator. We talked about that. Least common denominator. Well, the denominators we have are 28m and 7m cubed. So I want you to use prime factorization and list, just do prime factorization on all of them. So 2 times 2 times 7, those are all prime numbers. That equals 28. And then you got to list all your letters. Well, there's one m up there. Okay, so now everybody do 7m cubed.
1 times 7 times 8.
1 is a given, we don't put it up here. And you have 3 m's. Okay, so everybody has that as their prime factorization. Now, this is much different than greatest common factor. Here you have to list everything that's used, okay, and the most letters. So everything that's used, we have a 2 that's used, and that's going to be twice. We have a 7. They don't have to be common. So the greatest common factor, they have to be common. They don't have to be common here. What? Because I have 2 2's. That's what I'm saying. You want the most frequent number of things happening. So I have 2 2's. I need 2 2's there. I have 1 7 here, 1 7 there. The most frequently they're used is 1's. Okay? I have 1 m here and 3 m's here. I'm going to use all 3. Okay? Alright, so that's really 28m cubed. That's your least common denominator.
Oh.
Why wouldn't you do the 7?
Because it's common with the other set.
The most frequently it's used in each number. So the 7's used once here, it's used once here. It's at most used 1 time. The 2's used twice here, 0 times here. What's the biggest frequency it's used? Twice. Got it? M's used once, it's used 3 times here. The most frequently it's used is 3 times. Got it? Alright. Alright, so that's the least common denominator. That was example 1. You've actually done this before. Y'all look at me like, I don't remember that. Must be a moron. Example 2. Marker. Yeah, it is. That's recyclable. It's plastic.
But if I think it.
Not anymore.
Mrs. Omi would eat you.
Go ahead and write this down.
He's a pilot, he doesn't care.
2 over x squared plus 4x minus 5. And?
No. I can't see.
Oh my goodness.
Thank you.
Over.
You guys
I feel like I'm gonna factor this.
Simon.
What is No. What? Don't you know I want to go outside?
That over.
Why can't we learn outside?
Yeah.
I don't want to do this. You know what? You're not leaving this room until we're done. So, if we're not done, meaning if we're not done, when the bell rings, you're not leaving.
What?
The fun Fridays aren't even fun.
You can move on.
I'm not complaining. I'm just.
Alright, so let's take a look at each denominator. X squared plus 4x minus 5. X squared plus 7x plus 10. I want the prime factorization. What do you think we're going to do? So, welcome back to chapter 9. Back to that, please. Everybody on your own. I told you if you didn't master it, you're going to be miserable. So those of you who are moaning and groaning, I can tell that you were the ones struggling in chapter 9. What?
Yes.
I don't want you to give me the answer. I want you to write it down on your paper.
Yeah.
I wouldn't mind factoring.
This type of factoring is easy.
Yeah, I actually like that.
Hey, I loaded it now. I get it now. This is no.
Let me get it done. Oh yeah.
Yeah, but now, what is the actual
I don't know.
common denominator?
X minus X plus
X plus
5,
five.
X minus 1, X plus 2.
Correct.
What?
What?
Sophie.
Sophie, dang.
I mean,
What?
I don't know.
X plus 5, X minus 1, and X plus 2.
Oh, I don't know. Oh,
Well, you have an X plus 5 here.
yeah.
It's used one time in this number. It's used once here. So you're going to use it once here. X minus 1 is used once here, 0 times here. At most, it's used once. You're going to put it down here one time. X plus 2 is used once here, 0 times there. At most once, you put it in. Yes?
So for these kind of questions that are homework, is that going to be amazing?
If it's asking for the least common denominator, yes. I'm just showing you how to do it. I don't want anybody coming in Monday saying, "This is hard, I didn't agree on 5 least common denominator."
Okay. Thank you.
When people are stressed and crying, they tend to sound a lot like that.
I don't.
Example 3.
Yeah, you do. No, I don't, Brody. You do.
5a over a plus 3 and a plus 6 over a minus 4.
You're going too fast.
He's writing it.
Just write the problem down.
He's late.
Calm down.
Alright, everybody figure out the least common denominator. It should be simple.
It's not that hard, I don't think.
Should be equal to me.
You should already know it without even writing anything down.
I know.
Can you factor either of the denominators?
No.
Okay, if I ask you to do this, what is the least common denominator? How did you come up with it?
Multiply them together.
Okay, multiply them together. Well, you can't simplify these any further, so your answer for the least common denominator is a plus 3 times a minus 4. Okay, that's the whole point. So what we're doing is we're getting you ready to actually add these things together.
Didn't we,
We're not even adding them yet.
do we,
Least
foil
common
that?
denominator part 2, there was.
Hey, do we foil that or what?
No, not yet. Alright, example 4. So let's actually do one.
That was. Oh my god.
3 over x, I'm sorry, 2x, 3 over 2x, plus 7 over 5x to the 4th. First of all, before you get started, what is the least common denominator and how do you know?
X like this.
To the
5x to the 4.
Alright,
2x, 5x, 10x to the 5th.
there's 3 m's here, there's 1 m there. We
10x to
use
the
3
4th.
m. Yeah, 10x to the 4th is going to be your Now, what are you supposed to do? How do you get your denominators to be the same? Well, what do I need to do here?
Multiply
By
5x to the third.
Multiply top and bottom. 5x to the third over 5x to the third is 1.
Yeah.
Yeah.
Whatever you do to the bottom, you have to do to the top. You act like you've never had fractions together. The process is exactly the same, guys. What am I going to multiply over here?
2x. 2.
You already have the x to the fourth.
Oh, yeah.
Alright, so therefore we have 15 x cubed over, no, it's the same thing, plus 14 over 10x to the fourth.
Is that your answer?
Did you? No, you're not going to simplify because you just put them together. Okay. Now we're putting things together. Got it? Alright.
Yes.
Can you show another thing?
Yes, you can. It's the same thing.
Because they're common denominators.
It's a common. But then you're going to get this, what you started with. So you don't work yourself back into what we've been doing. Don't pull it apart once you put it together. Now we're putting things together, all right? Yeah.
So that would be our answer.
Yes, this is the answer. Yes, you can put them over that and then simplify, but then you get back to where you started with. And, if you give me that as your answer, I'm going to be like, what are you doing?
Just write down the problems.
I put these together and then I simplify them.
I don't get it.
Just write down what he has on the board, you'll be fine.
Alright, this is a little more difficult. Don't worry, I'm saving the big one for last.
Oh,
Yay! What is
We need to send this video to Bill Gates to see what he thinks.
Wait, why would that be funny?
No, did I not tell you about the Khan Academy?
No.
Okay, well he's been actually using this website, Khan Academy, Khan, to help tutor his son or daughter, I don't know who it is. And so he mentioned it at one of his meetings, and so that website exploded with all these people going to it. Now they have millions and millions of people using it. The guy's not a teacher who made the website, but he uses this technology to kind of explain how to do stuff. Well, I went in and looked at it, and the guy's right on. He did a good job, except it doesn't address apathy, it doesn't address students who are lazy, it doesn't address the problems that we have in our classroom. Well, because the guy's not a teacher, he doesn't get it. But they, it was on ABC News or some, I don't know what it was on, but they were like, why do you think he's doing such a great job? And then somebody would be like, well, he's not a teacher, that's why. It's like, why don't you just bash teachers across the globe? I mean, I'm busting my rear end trying to get everybody to do it.
Oh, that's
This guy's
mean.
getting rave reviews, and
That's good. That's mean.
yeah. But I mean, he had nothing wrong with the guy. The guy's doing a great job.
No, I'm talking about the guy who said it's because he's not a teacher.
Yeah. The guy who actually does the website, he does a great job. There's wonderful things on it, application stuff, and he does a good job explaining things. I mean, the website's a good website, but I just thought it was kind of funny that they were bashing teachers.
The teachers, I got their education from.
So,
Digestive system.
yeah, that website won't make you laugh. That's right. All right. So, what's your common denominator? Yeah. So, what do you got to multiply over here? All right. So you got to do this: y plus 2 over y plus 2, right? And then over here, what are you multiplying by? Y plus 1.
That's an easy one.
So we have y squared plus 2y plus 3y plus 3 over. got that?
Oh, I'm not done.
Oh,
I
sorry.
wasn't done.
Oh, keep going. Don't look up here.
I can't help it.
Don't look.
I've already started looking.
Alright.
No, you can't.
Yeah.
That's not a factor. Y plus 3, y plus 1 is only 4.
But if it was back,
Why can't you like use file and put the denominator?
You can. We'll probably have a bunch of different answers to look at one day, so it'll take a while to look at. But I'd almost rather you try to keep it the way we're doing it on the notes, so that everybody's on the same page. All right. Any questions on this one before I give you the ugly one?
I want another one.
Example 6. Times 5x. Fourth, that'll give you 10x to the fifth. But I don't need it to be 10x to the fifth. That's like, wait a minute, it's like this. Watch. If I say 1/2 plus 1/4, and you say, well, the least common denominator is 8. Well, that's wrong. It's not the least common denominator, but 8 will work, won't it? X to the fifth will work. You don't need it. You want the least common denominator. Okay? Alright. So, what?
So for adding and subtracting expressions, that would be your answer. Because finding the sum difference, y plus 5y plus.
Yes, that's your answer.
Okay.
Okay. Alright, here we go. 2z minus 1 over z squared plus 2z minus 8 minus. This is really ugly.
However.
Can you make it addition?
Z plus 1 over z squared minus 4. What?
Can I kill the math people? That would be
This is gonna take like 5 years. Why does this stuff even matter?
Okay, when will we need
Well,
algebra?
that's a great
That's what we're
question.
gonna teach you.
On the Khan Academy, they do application stuff, show you when you use some of this stuff. It's pretty good. And then what you're going to do tonight, and we'll discuss after we're done doing the basic stuff, is we'll discuss those things. You'll have some application style stuff to look at. But if you can't crawl, you can't walk. If you can't walk, you can't run. So we're doing all this stuff to make sure that you can do the basic stuff. If you can't do this, it doesn't matter what the application is. So I got to make sure you can do the basic stuff before we go further.
What I was meaning is when we get a job. What
Well, you won't need it when you're flipping burgers and asking.
No, I'm saying, what real life situation is this gonna apply to?
I don't know.
Math
Never
teacher.
need a math teacher.
A math
Be math teacher or an engineer.
You're asking a question about something that is so far above and beyond this class, when we've already talked this year that you definitely need these expressions to help understand in a bigger scenario of how to make things simpler. You define what x is, you define what y is. It's a line in a factory that produces so much of a product. This line produces another product. We're going to call that y. This line is x. They produce at this rate. They produce at this rate. When do they meet? When do they cross? When is production maxed out? When has it gone too far? When is it not enough? You see, you have to be able to put expressions into play, and then when you start doing that, you start adding expressions and subtracting expressions and multiplying, dividing expressions. And if you can't work those out, then it doesn't matter if you can put them together. Okay? So This is showing you how to work them out so that when we get to a point where you can say let x equal this occurrence. Because that's what algebra really is. And that separates the people from making 6 figures from the people who make, 5 figures. Yeah. $11,000 isn't very much. What?
Like, I still have the teaching my grade and that, so would you just take the left line times 3 plus 2 and then right line times?
Yep, what's missing here? We're missing a c plus 2. So we got to multiply this side by c plus 2. Don't forget, that's the whole thing you need to multiply. And over here, this has to be multiplied by z plus 4. Alright, so your denominator is z minus 2, z plus 2, z plus 4. Oh gosh. So now you need to do FOIL up here and FOIL over here. Everybody do that? I'll write it up here. And then combine like terms. Hey, just giving you a heads up so you don't have to erase a whole bunch. Hey. Yeah. Stephanie, there's a note on my desk for you. Yellow bus thing. Don't forget this minus sign. After you figure all this stuff out, it's minusing all of that. So I got a z squared, that's going to be minus z squared. That's a 4z, that's going to be minus 4z. That's a 1z, that's a minus
1z.
That's a minus 4. Alright, now combine like terms.
1z.
2z squared and minus 1z squared.
1z.
And we got a z squared. A 1z squared. You used to wear onesies?
Yes. I still wear them. You just pulled them.
Alright, we get z1 minus 1 plus 4.
I'm not very
1z. 3z.
Minus 1 plus 4 is 3. Minus 4 is negative 1. Minus 1 is minus 2. 2z. Twosies. Now we have a minus 2 and a minus 4. That's 6. And we have all this on the bottom.
Why do you put a line through your Z's?
What happens
So
if
you know the
separate
difference between a
them?
z and a 2?
Yeah.
What happens when we do this line?
She goes, okay.
You start to cry and you get all bored. And your new math teacher.
Bro, oh, bro.
I have a feeling that's exactly what they do.
I wouldn't say it wasn't true. All right. Assignment.
I did not like this.
What?
We got the missing view.
I already did it. No. Yes.
Take it off. Take it off. Take it